Unit 17, Part 2, we're talking about the multiplication principle, which is something you've probably done before, at least the tree diagram part, but we're going to look at probably a little bit more advanced way to do it as well. But we are going to start with a tree diagram. A tree diagram is one way to count the number of possibilities. Once you see what I draw out, you probably will have seen this before. So the directions say to make a tree diagram to find all the possible choices. So it says choose a sedan, truck, SUV, or minivan in red, blue, or green. So I would start by writing sedan, truck, SUV, and minivan. And then since it's a tree diagram, we're going to have branches that come off of this. So off of each of those will then come branches for the different colors. So off of this, I can go red, blue, or green. So red, blue, or green. I'm not doing the best job drawing this. So I have sedan, truck, SUV, and minivan, and then for each type I have 3 different colors. So now I can count up everything on the far right. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know that I have 12 possible choices. If this said choose a sedan, truck, SUV, or minivan, and red, blue, or green with a DVD player or not, then I would draw branches off from the end, and then I would always count from the very far right. Okay. So for the second one, it says to choose turkey or ham with white, whole wheat, or rye bread. I'll let you guys do that one. Make the diagram, tree diagram, and then count how many. So that's kind of the old version to do it. The new way to do it, or the faster way to do it, is the multiplication principle. It says if one event can occur in m ways, and for each of these ways a second event can occur in n ways, then the number of ways that 2 events can occur together is m times n. The multiplication principle can be extended to 2 to 3 or more events. So, really long definition, let's cut to the chase here. It says find all the possible choices. It says a menu has 3 choices for salad, 4 main dishes, and 2 desserts. How many different meals are possible if you select a salad, a main dish, and a dessert? So what all of that big long definition on the front page was saying is basically just multiply them together. So there's 3 salads times 4 main dishes times 2 desserts, and that gives me a total of 24 possible meals. So if I multiply all the choices, I wind up with 24 possible meals, meaning I could have a Caesar salad with a steak with chocolate cake, and then I can go through all the possibilities. Number 2 says, you're choosing a computer password. The password has 3 lowercase letters followed by 2 digits. So there's 26 letters in the alphabet. There's 10 total digits, 0 through 9. It says how many passwords are possible if there are no restrictions. No restrictions means I can repeat the same letter 3 times and then the same digit twice if I want, or any combination of that. So my 3 lowercase letters means there's 26 possibilities times 26 possibilities times 26 possibilities. So 3 lowercase letters and then 2 digits. 10 digits and then 10 digits. Again, that's 0 through 9 are my digits. So I multiply all that together. I get 1,757,600 possible passwords. For part B, it says how many passwords are possible if no letter or digit can be repeated. So this changes it a little bit. Still, 3 lowercase letters, 2 digits. So at first I have 26 letters, but then if I can't repeat, I only have 25 possible left. And then I can't repeat either of those 2, so I only have 24 possible. So there's my 3 lowercase letters. Then my first digit, again 0 through 9, is 10 digits, but I can't repeat it, so there's only 9 possibilities left. So if I can't repeat anything, then I have 1,404,000 possibilities. So the restrictions drop at about 350. The next part says finding a probability. It says for the following questions, you have a 6-sided number cube and a spinner shown. Six-sided number cube and the spinner shown, which you can't really see on here. So scratch that, the spinner's not in here at all. The spinner will be on your notes though. The spinner will look like this. It just has 4 possible sections. That's the worst drawing in the world. Okay, but your notes will have the spin on. So it says, the first thing it says is you spin the spinner 2 times. Find the probability that the spinner stops on 1, then on 2. Okay. So, when we're going to do this, if you look at first, I have 4 possibilities on the spinner. What I get on the first spin doesn't at all affect what I get on the second spin, so there's still 4 possibilities on that. So that gives me 16 possibilities, but only 1 of what I want. So my probability would be 1/16. The next one says you roll the number cube 2 times, find the probability to roll a 1 and then a 2. Okay. So the first roll, there's 6 possibilities. The second roll, there's 6 possibilities. So that's 36 total. But what I'm looking for is only 1 out of 36. The last one says you spin the spinner once and roll the number cube once. Find the probability that the spinner stops on the same number that you roll with the number cube. So when I roll, there's the higher number, there's 4 on the spinner, 6 on the number cube. So there's the higher number of 6. Once I get that number, there's only 1 though on the number cube. Sorry, there's only 1 on the spinner. So that'd be a 6, and then the probability is 1 over 6. Alright, these probabilities are probably pretty confusing. Just go ahead and ask me if you have any questions. And then there's review problems at the bottom.